All right, chemistry students, we're gonna have two videos on Chapter 12. Chapter 12 introduces you to organic chemistry. So if you move on and take Chem 1152, you need to know this foundational material. Now we're only going to do part of the chapter, okay? We're not going to do all of it. Also remember that your textbook is a custom-made textbook by the publishers, the same people that make your homework. And the first half is by the first author's last name is McMurray, and the second half is Timberlake. So all of Chem 1152, you're using the book that is the portion by Timberlake, and Chapter 12 is also by Timberlake, okay? I mention that because some of the tables might look a little differently than we've already seen in the previous chapters simply because it's a different author, okay? So we are going to, the first video is going to just define organic chemistry and kind of differentiate between it and something called inorganic, okay? Okay, and you're going to want to have your periodic table in front of you just briefly, or have it in your memory if you know enough of it, okay? And then we're going to define alkanes, alkenes, and alkynes, okay? So we're going to go through that. The second video is really going to look at functional groups, okay, which is the heart of the beginning of organic chemistry. But before we get to functional groups, we're gonna define it and go through organic versus inorganic for like the first 7 slides here, and then we'll get into the hydrocarbons, okay? So these are the sections that we're going to focus on. The later sections are about naming and that kind of thing, which you're going to go into probably in Chem 1152 if you take it, okay? So just to be clear, organic chemistry really focuses on carbon, 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 carbon. It's carbon-containing compounds. So we start with carbon, and we're going to spend a lot of time, like I said, in the hydrocarbons with carbon and hydrogens, okay? But organic compounds not just have carbon and hydrogen, they also have oxygen, sulfur, and nitrogen, and then sometimes the halogens. Now remember, the halogens were group 7A. That was like fluorine, chlorine, bromine, iodine, all of those, okay? So it was a group 7A. So just this slide alone, you could make like 10 different multiple choice questions about what is true or false about organic chemistry, okay? So keep in mind, we're just focusing on a few elements, okay? And I want you to, like I said, that's why I wanted you to have the periodic table in front of you, but I want you to remember the bonding patterns that we have already seen for all of these elements. For example, remember hydrogen just has a duet, so when it's in a covalent bond it usually looks like a line to a hydrogen. And carbon has 4 bonds usually to make the octet. And oxygen, we often see it, we kind of see it maybe with 2 lone pairs and 2 bonds, okay? Sulfur is the same as oxygen. Nitrogen is usually 1 lone pair and 3 bonds, okay? So if you remember, we've seen this table before that shows the patterns, and so there's like carbon with 4 lines coming off of it. It doesn't matter what it's going to yet, but you can start to see these patterns, and you're going to see these in the organic substances. So I wanted to refresh your brain and get you familiar with these again. Remember, oftentimes you will see oxygen with 2 lines and 2 lone pairs. The halogens listed here are often, because they're very electronegative, 1 line and 3 lone pairs, okay? So what we have here are the number of covalent bonds, and the really big important thing to note is carbon gets 4 bonds. 4 bonds, okay? Not more, not less. Carbon's happy with 4 covalent bonds, okay? So let's look at covalent substances a little bit, okay? Organic compounds are mostly covalent bonds. They have very, very low melting points. They also have very, very low boiling points. Now, an example of an organic substance that you're familiar with might be, for example, propane gas, or even just the gas you put in your car when you go to a gas station. Gas stations smell kind of funky because you're putting liquid gas, like liquid gas slash, I'm going to put fuel here, that liquid means, or this word gas means like the octane in the tank, okay? This LIQ means liquid like the state, like solid, liquid, gas, okay? If you're putting that into your car, into your gas tank in your car, the little bit that drips maybe onto the ground very quickly evaporates into the gas phase, so the state of the gas, okay, which is what you're smelling when you open your car door, and you can smell that the gas station doesn't smell like a fresh mountain breeze, okay? A lot of organic substances are very flammable, okay? If you think about it, if we have a lot of carbons and hydrogens, and propane is carbon and hydrogen together, very flammable, this next statement will be very true. Soluble in nonpolar solvents. Well, the carbon-hydrogen bond is nonpolar covalent bond, okay? So they're soluble in other nonpolar substances, and they're not soluble in polar water, okay? So organic substances are also often gases or liquid at room temperature, okay? Because I focused on the fact that organic substances are covalent, I want to kind of say, well, what is it not? This very last statement here, something that is not organic, that we would label as inorganic, would be an ionic substance, such as sodium chloride, that contains a metal with a nonmetal, okay? And that's this here, is trying to show an inorganic substance, okay? So those are opposites. Organic is a very small portion of the periodic table, but because carbon can form 4 bonds with a bunch of different things, there's a lot of diversity in organic chemistry, okay? So this table here came from a different book. If you see, it's actually a completely different chapter, but it lists certain properties like elements, particles, bonding, polarity, melting, boiling, flammability, and solubility. These guys I just went over on the previous slide. And then if you wanted to, you could kind of draw a line here. And the left half is organic with an example. And the right half of the line, there we go, so I won't strike through my stuff, is inorganic with an example. So they're comparing the propane to the sodium chloride here. And you can see, for example, the boiling point and melting point are negative a huge number in Celsius, okay? So that's really, really low boiling point, okay? And you can see not soluble in water, whereas ionic substances can often be soluble in water, okay? So this is a really good table also to refer to when you're comparing the two. You could come up with, you know, easily 25 multiple choice questions just from this table alone, okay? So that'll help you. Now, we're going to do some examples, see if you were actually paying attention. All right, identify each of these as inorganic or organic. So try to solve them before I flash through the answers here, but all I want, you could even put like I or O, okay? Because inorganic for I, O for organic, okay? Has a high melting point, inorganic. Is not soluble in water. Should make it clear that that's organic based on what we went through. Has the formula, now we haven't seen this kind of format yet, but we'll get to it. But you see a bunch of carbons and hydrogens, that's definitely organic. Magnesium is a metal in group 2A, so inorganic. Burns easily in air, that would be something that's generally organic, and has a lot of covalent bonds, letter F, organic. Okay, so get your categories straight before we start drawing them. All right, so now that we're into organic territory, all right, let's define a hydrocarbon. Basically, it's actually the two elements that you hear in the name, an organic substance that contains hydrogen and carbon, okay? The 3 main ones that we're going to go through are the alkanes, alkenes, and alkynes. And if you look, the spelling only differs here, A, E, and Y, okay? And I want you to remember that when we're doing all of these, carbon gets 4 bonds. So we're going to have carbon with 4 bonds, and the differences among the alkanes, alkenes, and alkynes, we're going to see, we're going to just change the number of hydrogens, keeping carbon with 4 bonds, okay? Your book goes into aromatics, which I'll do an example for you, but we're not going to dwell on them very much, okay? But those are essentially circular hydrocarbons, okay? So let's start with the alkanes. The simplest alkane is methane. Okay, so you're going to want a spare sheet of paper because we're gonna expand on this, but just start with simple 1 carbon and fill in. So 1 carbon alone, 4 bonds. You can make them north, south, east, and west, and fill in hydrogens, and that's methane. okay? Add a second carbon, and we're not going to leave it hanging like that. We're going to add the appropriate hydrogens so that carbon gets 4 bonds. Now if you see, I had to, I'm going to draw this way out here. In order to add this second carbon here, I had to delete, say for example, the hydrogen on the right, okay, from methane. Okay, so now I've got 2 carbons and a total of 6 hydrogens. You don't need to worry about counting the hydrogens, you just need to make sure you've got, need to memorize the number of hydrogens. You need to pay attention to the fact that carbon gets 4 bonds. So if I expanded this out to 3 carbons in a row, I'm still in the alkane territory, okay? And then you just fill in hydrogens, making sure the carbons all have 4 bonds. So this middle carbon is only going to get 2 hydrogens because the other 2 bonds are attached to the surrounding carbons. And then the right carbon gets 3 hydrogens, and the far left carbon gets 3 hydrogens to satisfy the octet. So do you see how we just increase the number of carbons and the hydrogens change slightly, okay? So what I have on the bottom of the slide, let me erase this, is the first one was methane, the second one is ethane, okay? And notice how I'm drawing these, they're all single bonds, okay? And you've seen the ball and stick form before. So this is ethane here with 2 carbons and 6 hydrogens, and this is also ethane in that ball and stick format that you've seen so often. So if we were actually going to write the formula, you see it's on the left, C2H6, okay? And then if we wanted to do it with the next one that contained 3 carbons, we could say C3H8 is what it was, okay? The general formula for an alkane to determine the number of hydrogens is this blue formula at the very bottom, CnH2n plus 2. So let's actually do that for this one that had 3 carbons, okay? You already know the answer is 8, N being the number of carbons, okay? So if C is 3, H is going to be, and I'll expand it out down here, 2 times 3, because it's not 3 carbons, plus 2, okay? So you can see it's C3H8. Now we already knew that because I drew this earlier, and you can add up your total number of H's and you'll see that it's actually 8. But what if I gave you like C9? You'd have to draw a lot to solve for the hydrogen on there, so you're definitely going to want to memorize this little blue formula for the alkanes, because all we're going to do is we're going to go from 1 carbon methane all the way up to 10 carbons, and you're going to need to know what these prefixes are. Right now you've seen meth and eth, and you probably know from life that this guy here is propane. Okay, so now you've seen prop. They all end in A and E because we're in the alkane territory. See, check the title of the slide, okay? So for simplicity's sake, though, let's try to draw some of these a little more easily, okay? So what we're going to do is, instead of having, so this is sort of like shorthand, there's actually a variety of shorthand choices. We have this full expanded formula here, and you could actually condense it down to whatever is here where I've put the X. You could just say CH3, and then there's my X again, okay? So here is showing on the left expanded, and on the right is sort of a condensed format. If we had like the middle carbon in that propane molecule, so who cares what's on the right or the left where my 2 X's are, you could take this CH2, and he is now just written out as CH2. Okay? The confusing part about this condensed formula is it kind of looks like this hydrogen here is covalently linked to whatever this X is on the right. But it's not when you see the expanded formula. So once again, those two go together. The left is expanded, the right is condensed. Okay? Let's do a real example, something that's a little bit bigger, okay? So this real example, if you kind of ignore the pink arrows for a minute, I'm boxing in the real example in a red box, okay? And I'm going to number my carbons. 1, 2, 3, 4, 5 carbons. They all have 4 bonds and the appropriate number of hydrogens depending on where the carbon is located, okay? So carbon 1 becomes CH3. Carbon 2 becomes CH2, which is what it is right here. 3, 4, 5, okay? Now the very bottom kind of looks like a big M. Do you see that? And we call that the superskeletal formula. So we don't even actually draw the C for carbon or the H for hydrogen, okay? So I have a blank slide that I'm going to go through this one more time with you. We'll probably just do 4 carbons, okay? I'm going to show you the full expanded, and then the condensed, which is what's at the top of the slide here, as well as right there. And then I'll show you the skeletal, because the skeletal is kind of the most confusing, okay? So like I said, we'll do 4 carbons. Get yourself a piece of paper. 4 carbons, okay? Fill in the appropriate hydrogens. So the far left guy, I'm going to actually number my carbons so you can pay attention. The far left guy will have 3 because he's only, carbon 1 is connected only to carbon 2. Now carbon 2 is only going to have 2 hydrogens. Carbon 3 is also only going to have 2 hydrogens to satisfy the octet. And carbon 4 is going to have 3 to give it 4 bonds total. So that's the full expanded format, okay? Now we're just going to simplify it into that condensed format, okay? Carbon 1, CH3, okay? Connected to carbon 2, which is CH2. I'll actually write carbon 2 here. Connected to carbon 3, which is also a CH2, carbon 3. Connected to carbon 4, I'll write the 4, which is CH3, okay? Now, if you were too lazy to write that condensed formula, so this condensed, we're going to have the skeleton format, and think of it kind of like connecting the carbons. The reason the lines are bent is because if I incorrectly did connect carbon 1 to 2 to 3 to 4, you can see it would just look like a bunch of lines, okay, one long line. So carbon 1, and we usually draw it for some reason down, and then we go up to carbon 2. Literally, that is the bond connecting carbon 1 to carbon 2. Carbon 2 to carbon 3, we're going to draw the bond again. Oops, excuse me. We're going to draw the bond again, okay? That's supposed to be a straight line. Carbon 3 to carbon 4, we're going to draw the bond again. Do you notice that we've got bond 1, bond 2, and bond 3? Those are the 3 single bonds connecting all 4 carbons in this alkane, or this hydrocarbon, okay? 3 bonds, 3 lines, 1, 2, 3, okay? You need to be familiar with the skeleton structure, especially if you're nursing interest. A lot of drugs are not written in the expanded format, they're just shown in the skeleton structure, okay? So practice drawing, pick any length you want, 8 carbons, and just practice drawing the line stick format, okay? The full skeleton format. You need to be familiar with any format. You need to be able to count up. If I gave you all of the lines, just lines, you need to be able to tell me how many hydrogens are present. Or go from expanded at the top down to skeleton, or vice versa. You need to be able to do all variations of it, okay, and recognize all variations of it. So I had mentioned those prefixes. I'm sorry, the bottom is cut off a little bit. I intentionally cut it off, but that says table from a different book, okay? So we have seen methane, the prefix eth for ethane, the prefix prop for propane. If you see, I've got 4 through 10, and the last one is decane, and here's your formula, the molecular formula, C10H22, and what this table shows you is just the condensed format, CH4 for methane, and then this long line here for the decane, okay? These prefixes are exactly the same for the alkenes and alkynes, except we just changed the ending. So instead of methane with an A there, I'm trying to draw an arrow next to the A, we have an E for methane. And instead of ethane, we have an E for ethene, and then it's propene, and then it would be butene, pentene, hexene, okay? For alkynes, change that A and ane, or E in the enes, to a Y and E at the end. But it's still the same set of prefixes. So technically, very, very similar. You're just memorizing 10 prefixes, but you can, excuse me, you can apply it to 30, excuse me, 30 substances. Okay, so you have to know these 10 prefixes. You have to memorize these 10 prefixes. This table did not come from your book. This is actually the one from your textbook, and it just shows the number of carbons, and then it has the condensed structure. It doesn't show the bonds, but it's the same thing. The decane is the same thing. And then it just lists the names. So these are just the alkanes on here, okay? Let's actually look at what on earth is an alkene versus an alkyne. Once you've got the alkenes and alkynes are actually a little bit easier. Okay, so alkenes have a double bond, okay? So we're actually not really going to look at, like methane doesn't exist because it's all single bonds, okay? So we're going to start with ethene with 2 carbons, okay? So if you see, ethene has 2 carbons, but now we're connected with something that looks like an equal sign. So you can have the full expanded formula, or you can do the condensed formula, okay? Or if you were actually going to draw it in the skeleton, it would literally look like an equal sign, okay? Notice that the number of hydrogens had to decrease because carbon 1 and carbon 2 each have 2 bonds in the middle. So I can't have it be, like, incorrectly. I can't say CH3 double bonded to CH3. No, that is totally illegal because both carbons would have 5 bonds, which is not ever going to happen. Okay? So the general formula, this blue formula that you need to know, is going to be CnH2n. Okay? So this, if you notice, the formula for the hydrogen changes. Okay? And if you're like, why do I need to memorize that? Because not only do you need to know the prefixes that I just talked about, methane, ethane, propane, butane, or methane, ethene, propene, butene, etc., but if I said N equals 6, what is the formula for an alkene? Okay, then you could say, all right, C6, H2 times 6 is 12. So that's the formula for an alkene. You don't need to worry about where the double bond would be among those 6 carbons. You just know that at some point a double bond does exist, okay? At some point. So I could have 5 carbons in a row, and I'm going to draw the skeleton, 5 carbons in a row, and it doesn't matter where, maybe between carbon 2 and carbon 3, I've now got a double bond. That is automatically in the alkene territory because at least one double bond exists, okay? This third bullet, I just want to make a note. Other elements, such as oxygen, can form double bonds, and you're going to see that. But when we're talking about carbons forming double bonds, we're in the alkene territory, not, say, oxygens forming double bonds, okay? These are just applied to alkanes, alkenes, and alkynes, which are carbons and hydrogens alone, okay? So if alkanes are single bonds and alkenes are double bonds, hopefully you can kind of follow the pattern that alkynes are going to have triple bonds, okay? And that blue formula that you must know is CnH2n, and then we have to subtract 2, okay? So you would have methine, propine, butine, or ethine, I forgot ethine, excuse me. All of those, you would need to know the names. You would need to be able to provide the formula. If I said if n equals 9, what is the formula and the name of the substance, okay? So here's the triple bond ethine, okay? Once again, if I have, and I'll even expand it fully out, let's just draw 4 carbons as an alkane with the appropriate, I'm not going to draw my hydrogens, but all those bonds would have hydrogens. If I all of a sudden said this is now a triple bond, I'd have to delete some hydrogens. This third carbon actually would have 0 hydrogens, and this last carbon, count your bonds, would only get 1 hydrogen in order to have the octet, okay? And the first 2 would stay the same. So that is also what I've drawn here, an alkyne, okay? It's got 4 carbons. So you're going to have butyne, okay? Ethyne here shows only just the nice simple, if you were to draw this out, CH to CH. There's a condensed format, okay? Once again, memorize the blue formula because you're going to need to know that. So as a summary for the hydrocarbons, oh, let me show you. This is the ball and stick for the alkene and the alkyne. But as a summary for the hydrocarbons, you need to know these formulas, and this would be a perfectly legitimate example of an exam question. If n equals 2, what is the formula for the alkane? And then what is the name of it? Okay? If you see, I've just solved it. C2H6, and then the name would be ethane. So I could give you anywhere from n equals 1 to n equals 10. You need to know all the way up to 10. Okay? So here's 2 examples. If you're like, wait, what was that? Here's 2 examples, and then the table that we saw earlier is given up at the top. So see if you can work through this. If n equals 3 with the formula, and I went ahead and just gave you the formula CnH2n minus 2. So that was alkyne territory. Okay. 3 is prop. Okay. So you might actually be able to solve the name faster if you memorize your prefixes. So it's propyne, C3, H, okay, so 2 times 3 is 6 minus 2 is 4. Okay. And it's going to animate in incorrectly. Sorry, that should be a C3H4, not a C2H4. That's a typo. Okay, so it should be a 3. All right, if n equals 3. Now, if n equals 5, and you should know what this is. These are the alkenes with the E-N-E. So if n is 5, where are you? Here. So you've got pentene. So it's kind of like Pantene, Pro-V, pentene. Okay? C5H10, and it's pentene. Okay? Before we move on to the next video, which is going to be functional groups, you're going to want to have a piece of paper, and you're going to want to have the extra PDF document that's going to show you a summary of all of the functional groups. You're going to want to have that in front of you and print it out so you can really see, because what we're going to do is we're going to replace some of these hydrogens with something else, and we're going to call it a functional group, okay? Because organic substances are divided based on functional groups, okay? So you're going to want to have that in front of you before the next video. So thank you for listening.